Hello guys, welcome back to my YouTube channel. In this video we are going to discuss about the topic Compton effect. What is Compton effect? And in this video we will also derive the equation of Compton effect, which relates the change in wavelength to the angle angle of scattering. Alright, so the basic concept of Compton effect is that suppose you have an electron, right? This is the electron, and suppose its rest mass is m naught, and you have a photon which is coming towards the electron, right? And suppose its energy is h nu, right? Having frequency nu, right? So since this is going towards the electron, so it will collide here, right? So it will collide here, and this photon will scattered in this direction. If it is supposed to be that the photon is scattered in this direction, the electron is going to be scattered in this direction, right? And now this electron will have some velocity because it gains some energy from the incident photon, and so its mass will be relativistic, means its mass will change according to its speed, as we know from the special theory of relativity. And since it was initially at rest, it had initial momentum equal to 0, but now it has some finite momentum which is p. Suppose it has its momentum is p. In the same way, this photon frequency is changed, so now its final energy is h nu prime, okay? And suppose this photon makes an angle theta, and the direction of the motion of this electron makes an angle phi. Alright, so we will use this, and now also suppose that initially this electron was at the origin of this x and y coordinate. We are going to use the Cartesian coordinate in a plane xy plane. Alright, so that's the diagram that we use normally. And now proceeding further, let's see, you know that the momentum of the photon is given by momentum of photon. It's very simple, you know, from the de Broglie relation, you know, p is equal to h by lambda. I am using this for photon. Alright, so it's better to write p naught, okay? This is for photon, or simply write photon here. Alright, so if you want to know the momentum for photon, h lambda can be written by c by nu, means h nu by c. So the initial momentum of the photon is let's call it pi. P for stands for photon and I for initial. So the initial momentum of the photon is h nu by c because its initial frequency is nu, and the final momentum of the photon will be since it has frequency in nu prime, so it will be h nu prime upon c. Now similarly for momentum of electron. Alright, so what will the initial momentum of the electron? It is 0. Alright, and the final momentum of the electron is say it is p, right? Just say it is p. And now look at the energy. If we have written all these things, then it will be quite easy to derive the equation, okay? So now look at the energy of photon. Alright, so what is the initial energy of the photon? So let's say I call it initial energy of pi, photon, and initial, so it is h nu, right? And what is the final energy of the photon? Look at here, it will be h nu prime, quite easy to write. And now look at the energy of electron. All right, so the initial energy of the electron, it is simply the rest mass energy. Rest energy, you can also call it rest energy. It has only rest energy because it is not moving at all, but due to its mass it has rest energy according to a special theory of relativity. So EEI, it has m naught c square energy, initial energy of electron. And what is the final energy of electron? Look at here, now its mass is m, which is relativistic mass, so it will be m c square. All right, so that's it. And now we are going to use the two conservation laws. The first one is the conservation of linear momentum. Okay, conservation of linear momentum. We apply this conservation principle both for photon and the electron individually. Okay, so first of all, look at for the photon. The photon is going in the x direction, so initially it has momentum. It will be ppi is equal to ppf. Okay, initial momentum of photon is equal to final momentum of photon, plus we have to add, because now we are considering the system of photon plus electron, and the initial momentum of electron plus the final momentum of electron. Okay, so look at here, the initial momentum of photon is I have written it here, h nu by c. So here we write it h nu by c. And the initial momentum of electron is, look at here, 0. So 0 is equal to, and remember we are using this conservation principle along, we have to write along x-axis. Okay, and now look at the final momentum of the electron, photon. So final momentum of the photon is h nu prime by c. Okay, but we have to take its component in the x direction, so h nu prime by c times cos theta. Right, so we have h nu prime by c into cos theta plus, and look at here, the final momentum of the electron is p. So if you take the component of p, so it will be p cos theta. So we have p cos theta. So we have h nu by c is equal to h nu prime by c cos theta plus p cos theta. And now we multiply both sides by c, so we will have h nu is equal to h nu prime cos theta plus p cp cos theta. All right, so from this relation we can write cp cos theta. Sorry, there was some mistake. For the component of this momentum p, it will be cos phi. Okay, sorry, it was mistake, so it will be p cos phi. Okay, so we have cp cos phi is equal to, it will be h nu minus h nu prime cos theta. Let this be equation 1. And now we apply the conservation linear momentum along y-axis. So what will be along y-axis? Look at here. So along y-axis, the initial momentum of photon will be 0, because if we take its component, it will be 0. So 0. And what is the initial component of electron along y-axis? Since its initial momentum is 0, look at here, so it is also 0. So LHS becomes 0. And now look at here, the final momentum of photon is h nu prime by c. So if you take its component along y-axis, so it will be h nu prime by c times sine theta. So we have h nu prime by c times sine theta plus for the electron, it has final momentum p. If you take its y component along this direction, so it will be minus p sine theta, because it is a negative y direction. So we have minus p sine phi, sorry, it will be sine phi. So if you multiply c by c both sides, so you will have finally Cp sin phi is equal to h nu prime sin theta. So we have these two equations, and now what we do is that we square these two equations, squaring both sides in this way, squaring both sides, and we add it. So we will have, look at here, Cp square sin square phi plus Cp whole square cos square phi is equal to, it will be h nu minus h nu prime cos theta whole square plus h nu prime sin theta whole square. You know, Cp prime, Cp square can be taken as common, so in the bracket we'll have sin square phi plus cos square, so it will be 1. So that means on the LHS we have p square c square is equal to h nu minus h nu prime cos theta whole square plus h nu prime sin theta whole square. We can simplify it later as well, so no problem. Let this be equation 3. So now look at the conservation of energy. This was all about the conservation momentum. Now we apply the conservation of energy. Now we apply the conservation of energy. So you know the initial energy of the photon is h nu. So we have h nu, and the initial energy of the electron is m naught c square plus m naught c square is equal to, now look at the final momentum, energy of the photon is h nu prime. So we have h nu prime, and the final energy of the electron is mc square. So we have here mc square. From this equation, you know, if you subtract this from this, then it will be equal to the kinetic energy of the electron. I will tell you later how it is. So mc square minus m naught c square is equal to h nu minus h nu prime. Okay, and this term is equal to the kinetic energy of the electron. So remember it, we'll use this equation in a while. So we have this equation 4. So how is this? The kinetic energy of electron is equal to mc square minus m dot square. You know, from the special theory of relativity, if you read it, that the total energy of the electron is equal to m naught c square plus kinetic energy, some kinetic energy of electron. So that's how it is done. Mc square represents the total energy of the electron, whether it is in motion or is it at rest. Okay, so we have 4 equations. We also know from the energy momentum relation that E square is equal to P square C square plus m naught square c raised to the power 4. Okay, so we will also use this equation, of course. So here, look at here, E, we use this equation for the electron, right? For electron. So E, the total energy of the electron is m naught c square plus the kinetic energy of the electron. So it is whole squared, and look at here, p square c square plus m naught square c raised to the power 4. So on the LHS, we just simplify it, so it will be m square c4 plus ke square plus 2 times of ke into m naught c square, p square c square plus m naught square c raised to the 4. You know, this and this will get cancelled. And look at here, the kinetic energy of electron is equal to h nu minus h nu prime. So h nu minus h nu prime whole squared plus 2, we replace it h nu minus h prime, so we have h nu minus h nu prime times m naught c square is equal to p square c square. Let this be equation 5. Okay, so we have this equation. Look at the equation number 3. It is p square c square. So we can use the value of p square c square from equation 5 in equation 3. So we simply replace this p square c square. So we have h nu minus h nu prime whole square plus 2 into h nu minus h nu prime into m naught c square is equal to, here h nu minus h nu prime cos theta square. So we have h nu minus h nu prime cos theta whole square plus h nu prime sin theta whole square. H nu prime sin theta whole square. So we just have to simplify it. So look at here. What we do is that we just square it and square it here and then go further. So here we have h nu whole square plus h nu prime whole square minus 2 h nu into h nu prime, and here just leave it as this. So h nu minus h nu prime times m naught c square is equal to, now look at here, it is h nu prime whole square plus h nu prime cos theta whole this square, and it will be minus 2 h nu into h nu prime times cos theta, and here it will be h nu prime whole square into sin square theta. Okay, so look at here, this and this. So h nu prime will be taken as common, and so cos square theta plus sin square theta, this will be equal to 1. And you know, here this and this term gets cancelled, and so we have h nu prime whole square plus 2 into h nu minus h nu prime m naught c square minus 2 into h nu into h nu prime is equal to, look at this here, so it will be simply h nu prime whole square, okay, minus 2 into h nu into h nu prime times cos theta. So again, now this term and this term will be cancelled out. So now what we do is that we have this equation, 2 into h nu minus h nu prime times m naught c square is equal to, we are taking this term to the right hand side. So we will have 2 into h nu times h nu prime minus 2 into h nu times h nu prime into cos theta. Okay, so proceeding further, you can take 2 h nu into h nu prime common. In the bracket we will have just 1 minus cos theta. So now look at here, this and this 2 will be cancelled out. Okay, so what we do is that, look at here, so now we have finally h nu minus h nu prime times m naught c square is equal to h nu into h nu prime into 1 minus cos theta. So if we simplify this equation further, we can write h can be taken outside, so we have this and this, just write the c, and it will be h nu divided by m naught c, and we had already times h nu prime into 1 minus cos theta. We have simply bring this m naught c to the RHS. So now we can cancel this one h, and so we have now we can write here nu minus nu prime times c divided by, we bring this nu and nu prime on the LHS, so we have nu times nu prime is equal to h by m naught c 1 minus cos theta. So you can write nu prime minus it will get, so h upon m naught c times 1 minus cos theta, and just two step further, so multiply by c, so c by nu prime minus c by nu is equal to h by m naught c into 1 minus cos theta. C by nu prime, it will be, now c by nu is wavelength lambda, so it has lambda prime minus c by nu is again lambda, but it will be lambda is equal to h by m naught c into 1 minus cos theta. Alright, so this is the simple form of Compton effect. Okay, you can also write this lambda prime minus lambda. This is the change in wavelength of the light, of the incident light, or you can say of the incident photon. H upon m naught c, this term is also known as Compton wavelength. Compton wavelength. Alright, because the unit of h upon m naught c is just meter, and meter is the unit of lambda, which is wavelength. 1 minus cos theta, you know theta, remember that theta is the angle scattering of photon, right? Scattering angle of photon, and this equation gives the change in the wavelength of the photon or the light or any wave that you are using. And m naught is the mass, the rest mass of the particle. It is not necessary that m naught will be always the mass of the electron. It can be proton, it can be atom, it can be even molecules or any other particles. Okay, so that's it. And from one more thing that is important, very important, is this equation number 4. You know, Ke is the kinetic energy of the electron. So this equation suggests that the kinetic energy of electron is equal to the change in the energy of the photon, So h nu, you know, h nu is the initial energy of the photon, and h nu prime is the final energy of the photon. So h nu minus, so the initial energy of photon minus final energy of photon, that means the photon, as it gets scattered or when it collides with the electron, it loses some energy, which is equal to the h nu minus h nu prime, and this lost energy is appear at the kinetic energy of the electron. So this is a very important relation, and it was a very important discovery in the 20th century, right? It was discovered somewhere around 1924, right? Somewhere around this, I don't know the exact date. Okay, so that's it. So I hope you understood it. So you can also take the screenshot. So this is the first page, right? This is the second page, and this is the third page, and there is one more page, and which is here. This is the fourth page, right? So you can watch this video by increasing your speeds. I took some long time. Okay, so thank you, and see you later in another video. Thank you.